So when we say SDN, software-defined networking, this is an approach to networking, IP networking to be exact, that uses software-based controllers or application programming interfaces to communicate with the underlying infrastructure. In a software-defined network, normally you are already separating the control plane and the data plane. You might have already um, tackled this one in the video a while ago. No? So back then, before SDN was even developed in networking in general, majority of the configurations that we have to do to our networking devices, especially to our switches, no, is that we go into the CLI or the command line interfaces of these switches. We configure the necessary protocols, load the different configuration files on that specific device. And then we now depend on protocols to ensure that there is network convergence across your network, right? So when we say network convergence here, it just means that your different devices are communicating with each other. If there is a specific fault within one or any of the links in your network, the network is able to detect it, and packet forwarding can be rerouted accordingly. Okay, now pre-SDN, we have to do this on the device level. In other words, we have to go through the different devices one by one and then configure them one by one, and then rely solely on different protocols to ensure that all of the devices are forwarding our packets accordingly. So there is still a sense of isolation across different devices. When we go into SDN, a more technical term here. So a bit of a step back here also as well. If I'm going to split the functional components now of our switch, this can be split into two parts. You now have your control plane, which is where you do majority of the configurations in your device. This is also the plane responsible for configuring your protocols. This is also the plane where you set up your parameters. Okay, this is also the plane where you essentially tinker the device itself. Okay, so that's one. And then the other part is the data plane. So this is the plane responsible for forwarding the packets. Okay, so whenever a device or the switch receives that packet, it is then now the functionality of the data plane to ensure that it goes to the next device it is intended to forward to, or it drops the packet altogether. And the process on how the packet is being worked on is dependent on what you do in the controller plane, on what configurations you do in the control plane. Okay? So that's how you separate both the control and data plane now. Now in an SDN environment, it's just a matter of just centralizing the control plane as one large logical node, right? So as you may have seen, or as you are now seeing here in the diagram in our switch, no, the control plane now is now centralized as one component or one entity called the controller. And this is where majority, or in fact all of the configurations are being done. And to put it also on, if you might recall, Noel also has mentioned that in their specific network, they are also using SD1, their environment. And it's just a matter of them loading the template needed for their devices. And they're just now depending on the SDN controller to propagate those configurations across all of their network switches. So that's how, in general, an SDN would work. You have a centralized means of controlling all of the devices connected into your network. Okay, this process is a move away from traditional network architecture in which individual network devices make traffic decisions based on their configured routing tables. Okay, now the SDN architecture in itself, no, we take the term SDN, software defined, because in a way we are already decoupling or separating the dependencies between the software and the hardware. And with the software, that means the configuration or the control plane. SDN moves the control plane that determines where to send traffic to software and leaves the data plane that actually works the traffic in the hardware. Okay? This allows network administrators who use software-defined networking to program and control the entire network via a single pane of glass instead of on a device by device basis. So that's what I have mentioned also a while ago, that in a traditional sense or in a typical networking configuration, normally you would go into the device or into the level of the device itself before you can do the actual configurations. But in an SDN architecture, you just now do all of the necessary configurations in a single entity. Okay. Take note what I have said here, that it is an entity. It doesn't necessarily have to be a single device. In fact, no, most of the controllers that we have in production nowadays, what we are using in, well, in almost any network in general, no, rarely do you see a single SDN controller, but the network perceives it as a single entity, no. So more of that one later. In fact, if I were to discuss about the architecture. Now, how do we break down now our SDN architecture? You can see the architecture to consist of three layers. Okay, I am just giving to you here a simplified diagram on what the SDN architecture would look like. Okay, so these three layers consist of the infrastructure layer, the control layer, and the application layer. I want you guys to focus really more on the two lower portions, the control layer and the infrastructure layer. Okay, so remember what I have said a while ago, that in an SDN architecture, you are essentially decoupling or separating the control plane from the user plane. So this is actually also an illustration that um, this is an illustration that actually perfectly describes how that separation would work, right? So in the control layer, this is now where your SDN controller would rely on or would lay. And then on the underlying layer, the infrastructure layer, this is where your forwarding switches would come in. Essentially, what you're doing in an SDN architecture, if I were to put it bluntly, you're essentially creating dumb switches. Don't take it as a derogative term, but what we just mean here is that you are already removing the forwarding capabilities or decision making capabilities of the switch and just passing it on to a more centralized device, which is your controller. Okay. Now, across all of the three layers here, all of them are now communicating via application programming interfaces or APIs. Okay. So using our control layer here as a reference point, APIs facing towards your application layer or your services are now what you would call northbound APIs. Obviously so, because it faces north or goes up towards your application layer. And then the southbound API here is the control layer communicating downwards or towards your forwarding switches. Now, notice also here in the diagram, no, that for the controller to communicate to your forwarding switches, you also need a protocol. And that protocol is your OpenFlow. So in a way, I'm already introducing to you here what OpenFlow is, right? So you can think of OpenFlow as one of the protocols used by the controller to communicate to the forwarding switches. Okay. Now, on the briefly touching here the application layer, this is where majority of the services of your SDN architecture would also reside. There are some networks that implement several applications, and when I say applications here, I'm not necessarily referring to end user applications, but applications normally used in a typical network, and these come in the form of services. So this can come as load balancers, firewalls, no, anti-DDoS, no, among others. No, because in SDN architecture, there is the presence of having components to be software defined. You don't necessarily need firewalls, application, load balancers, DNS, anti-DDoS, web filtering to be physical components on their own. In fact, majority of the controllers being offered right now in the industry space are already they already come pre-embedded when you purchase a controller, meaning that it's just a feature found inside the controller itself. So in a way that the application layer and the control layer can be treated as one component or one set of equipment. Okay. Now, moving forward, no. So what I have explained here, these are just the functions of the different layers of your SDN architecture. Note that the architecture is a generalized architecture. So meaning that how it's then implemented by several manufacturers or vendors, no, it's already up to them. But in a way, that is how you would normally see it, no. So whenever say a vendor offers an SDN-based solution, no, expect that they would have their solution to have these three basic components inside. Okay, so there's the application layer, the control layer, and the infrastructure layer. And then, of course, for everything to be communicating, you also need APIs. Okay, now a caveat about APIs, because I have not briefly discussed this one. APIs or application program interfaces, although you may have heard of them, not just in the context of SDN, no? There's really no set of formal standards for the controller's node-bound API. So meaning that how you also make your devices communicate with each other, there's really no set rule. It still depends on what the manufacturer is also able to support and also able to deliver. Okay. Now, so that's what SDN is, software-defined networking. Now, how does it now compare to a traditional or a conventional means of IP networking? So I have here a simplified here diagram. So you'll notice that I have here a diagram, as well as if I were going to compare them line per line, you'll notice now that SDN, definitely it is already software based, meaning that the functionalities are no longer tied to a physical device, and they can already come as features, right? In SDN, control is centralized via an SDN controller. Now, about the topic of the SDN controller being a centralized entity, this can actually come as like both an advantage and as a disadvantage. So we are already discussing here its disadvantage, its advantage, meaning that we see now that because it is just a single pane of glass, meaning it's just a single entity, it's easier for network engineers and network architects to configure everything within their network. Okay, but this comes also with a compromise, no? Specifically security, okay, and also points of failure. Okay, so within security, no? Security is centralized, meaning that on one side, because you have only a single entity or a single network element that you have to ensure or to reinforce, no, process is simpler. However, you have to make sure that vulnerabilities do not easily penetrate or do not easily expose your controller to malware or to possible attacks. Okay, so that's why I mentioned here, no, security is both a strength and a possible risk. It's just a matter of the organization weighing out whichever it is that is beneficial for them at that given time. Okay, so that is also why it is important whenever an SDN architecture or an SDN solution is being applied into a network, you also have to make sure that all of the necessary security methods and security features are turned on. no? So because we do not want any possible external factors be um, causing a possible attack, of course, in a network. Well, you know what I mean here, no? Okay, now I'll now discuss what are the different benefits and also limitations of applying SDN. So you may be wondering already, no? Okay, sir, since SDN here is already, it's not a relatively new technology, why are companies still using it? Why are organizations still using SDN? Are there other relevant technologies that can surpass or even outweigh what SDN can offer? So here I list down four generic benefits. The first one, simplified policy changes with an SDN. The administrator only needs to configure a simplified network, especially in the configuration, because you just have the controller to configure. You don't necessarily have to configure the individual network devices anymore. Okay. Having said that, there's also network management and visibility. Only one centralized controller is needed to distribute policies to the connected switches. Okay. And because everything is already centralized, you also simplify your hardware footprint, right? So meaning that back then, when you have to say purchase 100 switches, no, each of them has their own configurations and intelligence. Why not just purchase a hundred dumb switches and purchase one logical controller, no, and leave everything else as savings. So that is also another factor to consider, no. So some of the offerings right now by vendors and manufacturers are, of course, they offer intelligent switches as part of their portfolio. But in terms of cost, of course, it would be relatively expensive, say, to a simple switch, right? So, say, one vendor offers an intelligent switch that is capable of up to L3 routing, and it also has firewall and fault detection. I'm just giving here an example. And that switch, say, is $500. I'm just throwing numbers here now. Try to purchase that specific switch and configure it in a network that requires 100 of those switches. So how much is that already? Compared to, say, purchasing $100 L2 switches and just purchase one controller, right? So that is where already some costs would be, or some organizations would prefer the second option over the first option, right? Because you're not just paying for the outright purchase of that equipment, right? So that's considered already as your capital expenses or capex. You also have to consider the operational costs and the maintainability of the device, where OPEX would now come in. Okay, and then lastly is network innovations, because of the concept of having it as software defined, and we all know how easy it is for us to improve on and even enhance features when they are already software based. SDN is also able to reap this said benefit. Okay, so meaning it is now possible to just purchase a hardware controller as it is, no, and in a matter of upgrading or enhancing the features, no, you just purchase the software separately. And when that software is already reaching its end of useful life, it's just a matter of reloading a new set of software, a more upgraded version of it, while retaining the hardware for your controller. So you're already saving up on the hardware aspect. On the flip side, say you still have you want the full capability of the software, and it is more developed and improved on compared to the hardware, and so much so that the software can easily be migrated to several controllers, or you can just take the piece of software and take it and load it to another controller altogether. That's already doable. Okay, because again, you're already decoupling the hardware and the software from each other. Okay, so those are the benefits, and these are just a few. Now, what are the challenges and limitations? Again, SDN as a technology, um, it also has its own sets of limitations, right? And what are the possible challenges here also? So here are four. First off, security. Okay, it is both a benefit and a concern, right? So because you are already working with a centralized network element, this can also mean that it is a single point of failure and a single point of vulnerability. Okay, assuming that you're not able to implement proper security measures and ensure that there is high availability in your controller. This is also why majority of how we deploy SDN in production, you don't literally have to deploy the controller as one entity altogether. Some of them can actually be implemented with an active or an active standby setup. Meaning, in an active example, in an active setup, you have essentially two physical devices working together. Okay, but majority of the traffic is just catered by either one. Okay, in an active setup, say you still have two devices, but one of them goes down. You still have this one to serve as your backup. Okay, or this one would just be triggered the moment that the active one is has failed. Okay, regardless, no. This is both security. There is still the presence of a security and a high availability risk here. So that's still a challenge in SDN. First, second one is unclear definitions. Um, almost everybody can offer SDN as a solution. Okay, each of them would have their own strengths, their own edge over the other competitors. And having said that, because it is diverse in that way, no, there is currently also no established definition for software-defined networking, unlike other well-established technologies such as, say, Wi-Fi or our mobile communication standards, such as in the likes of 5G. No, yes, there are some guidelines, there are some principles, but how these guidelines, principles, and standards are implemented, it's solely dependent on how the vendor is offering them, right? And having said that, the third item here is market confusion. No, you have a lot of solutions currently available right now in the market. You have Cisco, you have Nokia, you have Ericsson, you have Huawei, you also have Dell. Okay, among others, you also have HP. No, so some networking initiatives are often also mistaken for SDN. So there are a lot of products here available in the market now. Some of them can even be confused to be SDN because of the basic concept of separating hardware and software, or control and um, user plane. So that concept of separation between these two logical parts can often be mistaken also as SDN altogether. Just because something is decoupled, some might already conceive it to be SDN already. Okay? So, and lastly, there is slow adoption and also cost, right? SDN technology emerged around 2011 when it was introduced alongside the open flow protocol. But since then, adoption has been relatively slow, no? Even up to this date, in fact. Okay? Many enterprises cite the cost of SDN deployment to be a deterring factor. So it's not really much on the when we refer to the adoption, no, there are still organizations and companies who still use SDN. But how the SDN evolves in time, that is actually a bit of a challenge. Okay, so that is SDN architecture and its benefits. Now we go on to the model types. No, so I'll just briefly touch on this one. So we have four different SDN model types. So we have we have the open SDN. So meaning that when we say open SDN, network administrators use a protocol like OpenFlow to control the behaviors of virtual and physical switches. So think of these model types not to be working on their own, but rather complementary to each other. In other words, an organization can implement open SDN while also implementing hybrid SDN, if that makes sense. No, so it's not really a clear cut typing across all organizations. In fact, some of them implement a mix, or if not a mix, all of them, depending on the use case that they want to apply in their network. Okay, so that's open SDN. SDN by APIs, instead of using an open protocol such as OpenFlow, APIs control how data moves through the network on each device. Remember what I said a while ago, that if I were to go back to the architecture, no, so there is the controller communicating to your data plane. You have there the southbound API. You also have in the open source perspective, no, you have the open flow as a protocol communicating between the controller and the forwarding switches. In the SDN by API, you don't necessarily need open flow for the controllers to communicate to your switches. You can actually develop your own APIs. And some manufacturers develop their own APIs so that the controller can communicate to the switches. So that's how this second item works. Okay. In the third one, SDN overlay model, another type of SDN, this one runs a virtual network on top of an existing hardware infrastructure, creating dynamic tunnels to different on-premise and remote data centers. So this is a bit complex on how it is implemented, but let me simplify it here. No? If you look at your network on the physical sense, you would just see there your end devices connected with, say, fabric switches. Right? So sorry, so your L2 switches. That is just what you're seeing there. But in a logical sense, no, the switches is able to support several networking layers on top of each other, meaning that although you are physically seeing there, say, five network devices, or sorry, five switches, no, one layer can be just three of them communicating with each other. Another layer would just be two. Then the other layer, everybody communicates. So there are different virtual networking layers running on top of each other. Okay, so that's how you would talk about the overlay model. Okay, then lastly, we have hybrid SDN. Okay, so this works by the key term here, hybrid. No, hybrid in the sense that you are also using traditional networking protocols to work alongside your SDN architecture. And based from my personal experience in the industry, the fourth one is normally what we are using nowadays. And you might be wondering, why are even we still using traditional networking protocols? No? Because of the amount, or, well, if you're going to consider the full rollout of that organization, say, I have, say I'm organization and I want to implement SDN. Currently, what I have here is the traditional means of networking. It is more costly for me as the organization to overhaul my entire network as is. There is also the risk of a possible downtime, right? So it can be costly and time consuming to implement everything or improve everything by the get-go, right? So instead, what I do, since I already have my existing network, why not implement SDN alongside my already existing network? So that's how hybrid works, right? Hybrid in a sense that it can work with SDN with traditional networking.